All right, thanks. Well, Alan has seen this part before anyway, so it would be his second time. Um, all right. One thing when you think about baselines is that most baselines are really not constant. They're a technical estimate of what's going on at a point in time. And so they're like a snapshot. This is what was occurring during this time period on these dates or this interval. And we've talked about this already in a lot of detail, but just in general, you should always think of like when your baseline is some number, associated with the time period, also think of all the other variables associated with it. What's going on in terms of the operating hours, what's going on in terms of the speed of equipment, like a pump or a fan, what's going on in terms of if it's got a weather-related load or an occupancy load. And a thing to know is, were there inconsistent existing operations, or was there failure of control during that time period? All of that stuff is important to know. And then, there's typically when you have to adjust a baseline, you're going to be using some form of data and engineering calculations. All right, now this is a sort of a conceptual thing. The WWHH stands for the what would have happened meter, because this is the funny thing about kilowatt hour meters. You can calibrate a kilowatt hour meter. You can check it for accuracy. And depending on your hardware, you can say this meter is accurate to this percentage. And the accuracy can be tested and assessed because it's all hardware stuff. But what you can't assess is the what would have happened meter, which predicts your future consumption. And that's basically what you're saying is if I had not hired an ESCO and I had not done this project, what would have my future utility consumption have come or become or been? And that has to be calculated based on field data or on engineering models that are used to estimate. But you can't really directly measure what would have happened because it's about a time in the future. You can make a prediction, and that's really what it is. And so to illustrate this graphically, I'm going to go to the next slide. And you see if you were using some form of kilowatt hour meter, whether that was a short-term monitoring measurement of some kind or it was a utility revenue meter, you can see, okay, here's the variation in kilowatt hours over the baseline period. It goes up, it goes down between 500,000 and maybe 800, 900,000 kilowatt hours. Here we go. And then you enter that little interval there where the two vertical lines have a short distance between them right there. And you see, all right, that's the construction period. We do that, and that's interesting. Consumption's going down. Now we've entered the performance period, and if we were using a meter, a kilowatt hour meter, we could be tracking the kilowatt hours there. But the what would have happened meter is what we don't have. We only have a model or prediction or estimation based on our measurements, whether short or long term, and maybe trend log data. But the savings, the avoided consumption, is really this gray area between those two things. And that's why when you're talking about utility meters, that what would have happened meter line or the prediction of future consumption is based on all kinds of variables which are related to the baseline, which we talked about, like occupancy, load factors, maintenance, all sorts of stuff. And the more accurate that is, the more accurate your prediction of the what would have happened meter is. So anyway, this is a really sort of fundamental thing conceptually, because sometimes people think, oh, I'm just taking this measurement of this one thing here and I'm going to compare it to that. No, you need to know the what would have happened. You know what happened in the past historically, but what would have happened is in the future if you did no project. That's an estimation prediction. No matter how much it's supported by data, it's always going to be some type of engineering model. All right, now we're going to get into some BWS savings changes examples. These are just a few that NORESCO was kind enough to assist in providing input on and suggesting that the initial solar panel layouts on reservoir roofs It looks like there were some changes to the clearance because you realized, oh, if you want to get in there and do certain kinds of operational work, you're going to need a different level of clearance, and that will change the quantity of panels at certain locations because, you know, you had to reduce, I guess, the size of some of those layouts on the reservoir roofs in order to make clearance available to do operational procedures. So that made a slight reduction in PV output. At least, Aaron, I'm assuming it was relatively slight. You can tell me if it wasn't.
We'll find out.
Yeah, relatively slight, no more than 5%.
Yeah, okay. Then we already alluded to this thing earlier, which is success in obtaining approval of PV interconnect agreements, really important. It sounds like the RESCO's ahead of the curve on this because they got in advance of these project designs, getting you agreements under the old net energy metering program, so you got a higher dollar payments for your kilowatt hour savings result, and that gave you some increased savings. And my recollection of the numbers on this, although it's been quite a while since I looked at them, was this has a pretty substantial value in terms of the value of savings, getting those higher rates for your PV generated kWh. Once again, you correct me if I'm wrong, but I thought that was pretty valuable to BWS, wasn't it?
Yeah, it was definitely. And on top of that, it wasn't included as part of the guaranteed savings. So it's kind of bonus for us too.
Yeah, bonus savings, even better. And BWS made a request to increase the lighting scope and HVAC scope at Lehigh Yard, and that picked up some increased savings that way too. And this is all, especially the first and the third bullet are very typical sort of types of adjustments to savings that you might get when you're still even in the sort of the design phase. So here's just an example, and they're laundry listed out. You add a scope for lighting and HVAC, you pick up some new savings, you change the layout of PV panel, system size, you maybe reduce the PV savings a little bit, and then you got a big bonus on the economic value by getting your PV interconnect agreements in ahead of time and getting the higher NEMs prior to them phasing it out. Always good to be ahead of the curve when they start changing the rules. All right. This I want to talk about stipulating values or stipulating specific parameters. And sometimes you talk to people in the M&E world and they tell you stipulation is a dirty word, you should never stipulate anything. Well, that's just completely unrealistic in my opinion and doesn't recognize engineering reality. The truth is, it costs money to measure stuff. And if it didn't cost anything, then we could spend our whole life measuring stuff down to the level of, you know, how many photons are dancing on the head of a pin. But the reality is, nobody has that kind of budget. And the other thing is, what you should spend, remember that graph on the trade-off between cost and accuracy depends on saving uncertainty and the value of the energy savings. So if the energy savings are really low or small, and the savings uncertainty is really small, then it's perfectly appropriate to stipulate an engineering value or maybe a savings based on some calculations, engineering calculations. If the savings are larger, but the uncertainty is still pretty low, well then you may be doing some reduced measurements, but you'll be stipulating certain values for performance purposes based on collected or observed data or reported data or manufacturer data, and that may be perfectly fine also. By the same token, if the savings are small, and that goes down to this box, but you know, but the savings are very uncertain and also small, then you have to figure out, you know, what level of money can I afford to spend and reduce uncertainty, but not overspend to reduce uncertainty. And then you get up into this last one where uncertainty is really big and savings are really big, and there you want to be not stipulating savings. You want to be doing maybe some more detailed types of measurements, you know, to the level of cost effectiveness. So that's just a way of thinking about the trade-off between the value of savings and the cost of risk and the cost of measurement and reducing uncertainty. And I find it helpful to think about a little bit those issues. So when is it appropriate to use stipulations? Well, here are examples. The usage factor is well documented. You've got really good data on the usage factor for the equipment. The agency is willing to accept the risk of, you know, some slight variation in a particular factor. The agency's got really good previous experience with a particular type of ECM. and they are comfortable with its technical performance profile. And there's a high probability of savings performance because the savings are relatively certain. Then all those are cases where stipulation, probably a reasonable approach. If savings are small, like I said, if savings are really small and no M&V is cost effective, then you're probably going to divert or revert to engineering calculations. Maybe you'll make some conservative calculations and everyone will stipulate and agree, hey, this is the most reasonable thing and we're probably being conservative, so it's fine to count these. If there's no other value that you get out of the measurement, then that's another reason why stipulation may be appropriate. And your stipulation is based on technically defensible and economically defensible assumptions or data, so that you're not just doing it, oh, I'm guessing about it, but you're actually basing it on some real data. Now, when may it not be a good time to be using stipulations as opposed to measurements of some kind? When the project savings are really big, I mean, very valuable. When the project is really complicated, there's a lot of variables that aren't stable. You're doing variable speed drives on fans. You really want to know if it's controlling a big fan motor. You want to know how that VSD is performing. You don't want to be guessing about it. And a stipulation that shifts a huge amount of performance risk to the customer, that could be an issue depending on the particular ECM. Or if the customer doesn't understand the project commitments and is really risk averse and says, I know it might be cheaper to stipulate this value, but I want to go ahead and measure it and I'm willing to spend the money. And that's how you get your M&V budget up to $600,000 a year. Anyway, I'll just tell you a little story about this because it's for the federal government. And I'm doing this project now with Housing and Urban Development. And their M&V guidelines say that you can use 40% of the value of annual savings to do M&V. And to me, that's just literally insane. I cannot imagine using 40% of the value of annual savings to spend on an M&V process. And I've argued with them before about it, and no other federal agency does it that way. But HUD, for some reason, makes you do some really expensive stuff in M&V, which is definitely not cost effective.
Is that a way to build staff?
I don't know. It's something. I mean, Anyway, hey, they're paying me a lot of money to now do it, to go through it, and I'm like telling them, you guys are crazy, but they pay no attention to me. They just say, we don't mind, we're going to pay you to do it anyway. Okay. All right, I want to talk just briefly about IPMVP.
Hey, before you go on.
Sure.
Stipulations, could you give an example of one common one? And the second thing is stipulations are usually implemented by agreement, amendment to the agreement.
Yes, that's true. A very typical one would be operating hours for lighting. Let's say that you report a certain number of operating hours for lighting in a particular building or zone, and the ESCO may have done some inspections, they may have interviewed operating staff, they may have done some field inspections and verification, and then, if everyone's fairly comfortable with a number, rather than putting a bunch of runtime meters out, I'm not saying, people do this all the time, but on occasion they may stipulate and agree, all right, the operating hours for this office are, 2,000 hours a year. That's it. We're going to use that as a value to use when we calculate lighting savings. That it's on these 2,000 hours a year approximately, and we're going to use that as a value. So that's a pretty common type of stipulation. And that would be reflected in the contract agreement, and it would even be reflected in the M&V plan. Here are the operating hours that are agreed to and stipulated for this particular building or facility. That'd be a very simple example.
Thank you.
But IPMVP, which is sort of I call it, it's a protocol, and it's important to realize protocol is not the same thing as a standard. It's very technical, and but it's like what I call a glorified cookbook. It gives you a lot of ingredients and a lot of recipes about how to do M&V and good practices and questions you should ask and things you should think about. But it's not a standard. It's more recommendations for these are good practices, but it was published originally, it was begun in 94, published in 96, and then revised in 97, and now every couple of years they come out with a new revision of it. And they get more and more technically sophisticated and complicated, and if you really want to have fun or you have trouble sleeping at night, you can read it. And if you're an engineer, you might enjoy it because it's actually pretty educational. But it goes through a lot of details. And once upon a time, I actually sat on the subcommittee that wrote part of the original IPMBP on the indoor environmental quality part of it, but that was many years ago. Now, one thing I have a little bit of a, the thing I would say is it gives you a lot of good material, but it still all depends on the expert judgment that's exercised by the ESCO in applying the IPMBP ingredients to a particular project at a particular site. And so you can't really eliminate expert judgment. And I know people would like to, but it's more of an educational tool that really helps you understand all the trade-offs and things in terms of accuracy and what good practices are, but you still have to develop a site-specific, project-specific plan. And that can be a helpful foundation. But the ESCOs are very conversant with it typically, and some agencies are, depending on how large they are and how often they do these projects. If you want to really go and download your own copy, you can go to the website. It's now administered by the Efficiency Evaluation Organization, which is worldwide. And or you can go to ASHRAE, which provides under Guideline 14, at least for options B, C, and D, they provide even more technical detail. They don't really for option A, which is most of what your M&B is. But EVO certainly does provide a lot of detail on option A. So what are the differences between these different options in the IPMBP? Well, in option A, typically there are some stipulated usage factors, and then there are some spot measurement where you're verifying equipment performance, and that could be measurements of KW. In option B, typically you have a little more dedicated metering, which is there for typically a longer period of time. I'm oversimplifying these, but it's sort of necessary to just make the differences between them relevant. Or production performance, like a dedicated meter for PV system output, where you're measuring the output and then maybe you're normalizing for irradiation, etc., solar radiation on it, and differences from year to year. And then you could have the full utility bill analysis, where you're looking at revenue grade meter utility data and trying to analyze that. But remember what we said earlier, you're going to be making a lot of changes there. And then there's option D, which is using computer simulation model to predict what the consumption would have been with the ECMs pre-project and post-project, and actually comparing the output of the simulation model to determine the savings from some specific ECM. And that gets used as well. Now, just a little secret about this. It's not really a secret, but which is the most popular option in federal projects, ones done by the federal government? Option A is 61% of all guarantees. Option B, 17%. Option D, 14%. And what happened to poor option C? Only 8% of the time is option C ever used. Why is that? Because actually it turns out to be really expensive. Despite the apparent, attraction of simplicity to people who come from a financial planning background and don't understand all the technical complexities of having to sort the signal from the noise, they think, oh, I'm just going to look at my utility bill and that'll be the answer. But it's not really that simple. And that's why option A is often by far the most cost effective and gets used the most frequently. I mean, it's literally 60%. And then B and D together add up to about another, 32% or so, and then you're down to, the last 8% is option C. So we touched on some of these earlier, but when you're looking at option A, B, C, or D, and you're trying to pick between them, you start asking yourself, well, how uncertain are the savings? what's the value of projected savings, how complicated, can I get other value from it, and you make a choice accordingly. So just a little overview of option A. When you're defining, it defines a baseline condition for a specific equipment or equipment system, and usually, as we noted, it's going to rely on some operational factors, some runtime hours, and then it's probably going to do spot or short-term measured data to look at performance factors. And this may involve measurement of one, or it may involve measurement of a few different variables. But the key thing is they're short-term, typically. They're not going to be repeated typically over and over again. And they're usually short-term pre-measurements, and there's some short-term post-measurements to quantify the changes that are occurring in key parameters. And then ongoing action may be that there are visual inspection of equipment on some sort of annual schedule or something like that to verify that the condition of the equipment, where it can be determined visually, is still what it should be, so that the measurements you took should still be producing the results you anticipate, because there's not some obvious problem with the equipment. Now, in Board of Water Supply, used option A in a couple different areas. One is that PV generation, post-construction PV output measurements, annual condition assessment, which I assume, Aaron, that means you guys are actually doing some physical inspection of equipment or sample of the PV installed arrays on an annual basis. Would that be accurate?
That's correct, yes.
Yeah. And then, real-time monitoring and notification as part of ongoing O&M, which is a great approach because, people should not get the impression that PV is maintenance-free. It's low maintenance, but it still requires maintenance. And to think otherwise is not realistic, especially when you start thinking about a 20-year time frame. The water system, there's post-construction power measurements and an annual condition assessment, and then monthly monitoring. Just out of curiosity, how are you doing your annual condition assessment of the water system measures? I probably read it, but I don't recall off the top of my head.
We're basically taking sample measurements for the baseline case and looking at system data, basically pumping data as the baseline. And with that data, we developed a model to generate savings.
I understand that part, but in terms of the annual condition assessment, what data are you looking at, or what equipment are you looking at on an annual basis?
Well, specifically for ECM2, the pump replacements, we're looking at the equipment itself, and we're doing, kind of like you say, site inspections annually. Gotcha.
Okay, so it is a physical inspection, which is what I presume, but I thought I would get clarified. And then you've got HVAC controls, lighting, and other building measures where you're doing some data logging and eQuest models, using them to calculate your estimated savings. And then post-construction, you'll be doing some measurements, and I'm assuming a similar type of annual condition assessment, physical inspection, and then monthly monitoring. Now, the monthly monitoring, is that going to be electronic in some form in terms of providing notices about ongoing O&M needs for bullet number 3 there?
Correct.
Yeah, that's what I presumed once again. But these are good examples of how you might put together sort of a combination of spot measurements, annual condition assessments, and monthly monitoring, at least in the case of the water system and in the case of the HVAC controls and lighting, to make sure that the O&M stuff is on track. And I asked Noresco to identify some potential issues that might arise for M&B during the Board of Water Supply project, and they noted, if you're using the energy management system to reduce excess air conditioning at Pertania during evenings and weekends, you want to be sure that it doesn't get overridden. If you've adjusted the operation or the set point, you want to be sure it doesn't get overridden unless there's a good reason to. If you're using the facility on that particular evening or weekend and you need to have it operated. But in general, the problem with overrides is when they occur, a lot of times they don't get set back to the proper setting, and that can reduce your savings. I'll just give you an example from a project I worked at here in the the Chicago area many years ago where they started, they agreed to certain fan schedules based on their history of the baseline. And then after they had the project installed, they started running the fans an extra 20% of hours annually. And it's like, well, sometimes people call that take back. You got more efficiency, but now you're doing a lot more work that you weren't doing before with those fans because you're running them a lot longer hours. That it cost them some savings. And as you look at trend data and real-time EMS data, you're going to monitor schedules. The reason you're doing that is to help maintain savings, but if there's a deviation from savings, if you're off of your trend log, the question is, how rapidly do you get the feedback, and how rapidly is there an appropriate response to that feedback data from the trend log data to be sure that the problem is corrected? And obviously, the quicker a problem is corrected, the less risk to savings, and that helps reduce savings uncertainty. So, a couple of things to think about going forward. Option B, which, Aaron, are you using option B anywhere in this project? I'm not sure that you are.
No, we're not.
Yeah, I didn't think you were, but just for the sake of education of BWS staff, I'll mention it. Here you define the baseline conditions, and this is often tricky with option B, because if you're putting in a dedicated meter on an equipment system, but there wasn't a meter there before, how do you define the baseline? And that's usually the limiting factor in option B. Unless you had existing metering of the baseline system of equipment, sometimes it's hard to figure out what that baseline was. And you have to build it up with engineering assumptions. And clearly, if you didn't have a meter before and you have a meter after, it's sometimes harder to figure out what's going on. An exception to this is the output from a PV system, where theoretically you never had a meter before, but you can certainly track the production of the output with a new meter. Since there was no pre, there's only a post, theoretically could go that way. Here you usually use long-term continuously measured data for both performance and operational factors. And some of them may be formulated based on, like in a cooling system or a chiller system, you may have 6 or 7 different points that you're monitoring and measuring, and then you build up a model from that and build it into your calculation of savings. This could be formed at the equipment or system level and goes on for the term of the project. It's more or less continuous and hence often expensive. Option C we talked about already. The real trick here is defining all the baseline conditions at the whole building level, and then you're looking at a combination of utility bill analysis, and if all you had to do was analyze utility bills, your life would be nice and simple. The problem is you got to chase down all the other variables that impact meter readings. I'll just give you my horror story on that one. I had a project here in Illinois, once again, 25 years ago. They wanted to use option C, the agency, it was a state agency, and they made 30 changes in the first year post-construction that had a material effect on the utility savings, and none of them were ones that were initiated by the ESCO. They were all things that were done by the agency. Well, start adding up the engineering time. Figure, $100+ an hour for engineering, and you had to chase down 30 of those changes and quantify and estimate the impacts on the meter loads. Got very complicated and very expensive in a hurry. And that's sort of the Achilles heel of option C. Now, if you're in some little school where the total utility bill is, $100,000, and there's very well-defined equipment, and there's very few variables that can make big changes, then maybe you can do option C and it makes some sense. A lot of other places it really doesn't. Option D is simply using computer simulation modeling, where you define baseline conditions, you build up a whole building simulation, and then you can look at the impacts of individual ECMs and how they affect savings by running them through a simulation of the whole building behavior. And you have to calibrate that with historical utility data to make it accurate, to be sure that when you put in historical data into your simulated model, it gives an accurate readout of what historical consumption was, and then you can use it to work as a projection going forward. It's usually used for more complex existing building systems where there's a lot of interactive effects between measures. And we already touched on this, but accuracy, really not necessarily a lot more accurate to use option A than option C if they're used appropriately. Option B and D can get you more accurate, but they're a little more expensive than option A. And this sort of explains that distribution of methods. People go, yep, for the relative cost, I'm going to go with the lowest cost, and I'm going to take the accuracy that I can get. And that accuracy level is probably generous. It's probably not usually actually quite so big. And on occasion, I'm going to use the medium cost methods when I think I need them more accuracy, 10 to 20%, 5 to 10%. But I'm rarely going to use the highest cost method that doesn't really get me any more accuracy, except in some, specific cases. So here's just some savings calculation technical details, especially for motor loads. You got to consider what the motor load factor is. If you just did go in and assume that the motor is loaded to 75%, but it's actually only loaded to 60%, and then you try to calculate your savings with an assumption without actually assessing the motor load, you'll make a mistake because you're going to overestimate savings potentially by overestimating the load on that motor. Same thing is important with speed. If you put in a new motor, you want to be sure the RPMs of the old motor is somewhat matched by the new motor. Why is this? Because if you put in a new motor with a much faster RPM, work equals force times distance, and even though you're using less force, you're going to do a lot more distance if you do too many RPMs, and you're not going to necessarily save the energy you thought you're going to get because the speed increase will offset your efficiency gain. Anyway, something to think about. Then the power factor can also degrade. That can also occur, and you have to consider whether it could increase your power factor penalty. And you have to decide, when you're replacing equipment, obviously if you're matching a variable frequency of some kind to a motor, you better be sure that they're going to work together in a way that is appropriate. If they don't, sometimes you can be burning out your old motors with new variable frequency drives, and that's not a pretty picture. So you want to specify the new motor characteristics, what is full load, RPMR, and power factor, etc. at part load. Have your technical specifications. I'm sure BWS has very detailed technical specifications already for your big pumps and motors. And I'm sure that Oresco had to meet all those requirements already, but just some details to think about from an M&V point of view. And here's an example for lighting, a technical example. The pre-ECM curve up there and the post-ECM, and you see the power in watts, and then you're looking at the hours of operation, and you're seeing here they've not only reduced the power level, but they've also reduced the operating hours by, and it looks like they got even like a little dimming control there at the very beginning, and from 6 to 8 where lights come on sort of sequentially, and before it was a hard off or a hard on. Anyway, you can see another simple example showing a pre and post type of a comparison. Now, what do you need to achieve high performance? These are some, I'll call it some ingredients for high performance on your projects. Reliable monitored data. You got to understand what the data means, and this is where trading is really important. You need an energy manager to focus on the performance analytics, so when they see the data, they understand what the implications of the data are, and then they can actively work with the site operators. And it really helps if this data is in a user-friendly graphical format. And if you can also do some monitoring-based commissioning of equipment, this may be coming from your trend log data or somewhere else, but all of this helps you chase through the feedback loop, optimizing your performance over time, and that's really sort of the goal. So very helpful to do. If you're trying to create high performance buildings or equipment, it's good to link your data collection and analysis to the results you're trying to achieve. All right, here's my, sort of begin with the end in mind. This is where I want to be. What data do I need to support that performance, and how do I need to analyze it? The other thing is to have a comprehensive systems understanding of your performance, because even if you're focused on specific equipment and you're using option A, that specific equipment still may be attached to other equipment, and problems with that other equipment can affect the performance of your equipment-specific system that you're trying to measure. It's helpful to really view building operation as like a learning cycle. Typically, when you go into the M&V, one of the benefits is that people understand at a finer level of detail exactly how their equipment is operating and what it's doing and why it's doing it. And that's a useful from an operational point of view. So anything that can increase the speed and frequency of relevant feedback can be very helpful. Now, what are some of the sources of monitoring data that you might rely on? Utility bills, a utility meter reading, weather data, building operation and maintenance data logs, reports on building equipment changes, or special periodic metering or measurements. And those are probably the more relevant ones for this particular project, especially that bottom one. So when you're monitoring energy savings performance over time, and this is where you're sort of settling in for the long haul on M&V, you need to do adequate training of the staff who's going to be looking at that data so they understand what it means. You have an advantage. You're already starting out with engineering staff who have engineering background, but I work at agencies where they don't have any internal engineering staff at all, and that is a little more challenging for them then. I like it if you can, have the data provided in easy to understand graphic formats, comparing performance with performance targets. And, the comparative approach is really sort of what M&V is about. What's my target? Did I hit my target? Am I exceeding my target? How much am I exceeding it by? Etc. Another thing on monitoring that matters is it provides an incentive for optimizing operation and maintenance and documenting system performance. Everyone is a little more careful when they know the results are being monitored and someone's going to analyze the data that's being collected. If no one's looking at the results that are coming out of a project, then you don't know what's going on necessarily, and you may not be as careful. I've seen agencies where they've got M&V reports that are like 10 years of M&V reports, and I say, well, who's looking at the M&V reports? Well, somebody looks at it for half an hour when it comes in, then we file it on the shelf, but we don't really read it that carefully to see what's in it, and you may not be optimizing your performance if you're doing that. Also, building operators, they get helpful data coming back to them out of the M&V system. It allows them to correct system performance issues. Once again, this is just a formatting suggestion for monitoring your M&V data. Reporting it in dollars, units, percentage, both numeric and graphical. Make it as clear as possible. Make the time periods as clear as possible, and enough narrative description so people understand what the data is. I can't tell you how many spreadsheets I've looked at, and when there's not any notes on the spreadsheets explaining what they did or why they chose that particular value or where the data came from, can make for some long calls. And if there is a variance from predicted savings, hopefully there'll be an explanation, a narrative of why there's a variance, explaining what the cause was and what the remedy or measures that might be taken in response to it are. So monitoring really is a way, like the annual inspections that NERESCO will be doing, helps support high performance, because they can look at what's going on in terms of the quality of O&M that's occurring. There may be some trend log data that they're looking at least in Britannia. They can look and see whether any of the equipment is causing an alarm or performance targets are being met. And it helps maintain and improve performance over time. Sometimes buildings warrant more detailed diagnostic monitoring for certain systems, and that may require a higher frequency to spot a particular problem. Or if you have to required to make a baseline adjustment, you may have to do some specialty data collection to figure out what exactly happened and how do we quantify the impact to adjust the baseline. And the other thing is, sort of at the end of the process of this monitoring review, there should be some sort of review approval process that should be well defined, where somebody from Board of Water Supply would be signing off and approving of the M&V report. Yes, we reviewed it, we had our review meeting, we went through it, we took appropriate steps to respond to anything or any issues that came up out of it, and now it's been approved and, logged away. There are some new monitoring and control technologies becoming available, lower cost monitoring equipment, some wireless controls, especially for lighting and things like that that are starting to make an impact. And for some EMS systems, there are performance dashboards that are coming out. I wouldn't say there's necessarily a huge amount of this being incorporated into this current project because of the nature of the ECMs, but Aaron, correct me if I'm wrong about that. Are any of these things playing a significant role in the M&V that you're doing?
No. Most of the anything more sophisticated like building controls we're adding to and modifying rather than starting from scratch.
That's what I thought. So it's more of an upgrade rather than whole new systems. Yeah. Okay.
Yep, you got it.
So when you're doing monitoring-based commissioning, there's a number of benefits to the extent that whether you're doing that commissioning through physical field work or through some sort of electronic monitoring and analysis. It helps you understand what's going on in your property and your facilities, your equipment, reinforces confidence in performance. It can help you justify additional funding if you spot a problem and you realize, hey, we could fix this if we would expend a little more money on a capital thing or make the system more resilient. And it helps you reduce risk that you're going to be straying off your performance target. So this is once again jumping back up to the 10,000 foot level and say, what factors affect system performance? Well, obviously the focus is on the mechanical electrical equipment, but then one step removed from that, there's the electronic controls to the extent they're applicable. Then there's building occupants and site operators. I tell people, don't forget the human dimension, because these people are very important in terms of how they interact with controls and equipment. They can have a big impact on performance. Then there's the ESCO contract and BWS staff. They also have an important function in monitoring project performance and executing certain tasks, especially O&M tasks. But then there's agency staff at a higher level, management staff, who looks at the system performance and assesses it. And then you've got the utility company who looks at it from their point of view, and the quality of power they deliver to you and the nature of their tariffs and changes in tariffs or fuel adjustment clauses, that can all affect your systems, the value of future avoided costs. And then there's state laws and regulations, which could impose new technical requirements. All of these things can affect your system performance, especially when you look at a 20-year time frame. So what's a high performance culture? The Board of Water Supply, sometimes it's very common in agencies when you have building operators, new equipment is put in, but if their training isn't adequate, they may respond with old habits of equipment operation. And that can be a real limit or sort of an upper limit or ceiling on what you can achieve performance-wise. So the ESCO really needs to train agency staff on how to not only use the new equipment, but understand the benefits of new controls and equipment and how to get those benefits, and point out how it benefits the operation and maintenance staff and the building operators. You want to really view the ESCO as a supportive performance partner who can help facilitate you achieving your goal of optimal performance. And usually it's the mutual learning through shared experience that can bring that about. And I encourage people to take that approach, and they will get better results from their projects. So why is training so critical? Well, these are some statistics from various training, O&M training journals, but 30 to 50% of maintenance failures are due to lack of knowledge by staff, because honestly we just don't invest enough typically in training staff And that's sort of a worldwide phenomena. And maybe as much as 20 or 30% of failures in maintenance or operation come from staff not following a best maintenance practice, even if they knew it, but maybe they didn't have enough time or they were spread too thin, and then something didn't get done when it needed to be, and so there's some loss there. And shockingly, and this goes back to the training issue, but 90% of maintenance staffs lack some knowledge of some best practices. They know it to a degree in some areas, but there are usually gaps where about 90% of staff have some gap in their maintenance knowledge somewhere in terms of best practices. And what's worse is the old timers who actually know a lot of stuff about how to operate and maintain facilities, they're all retiring. And they're going to have to bring in new people to replace them. There'll be a loss of 40 to 70% of existing O&M staff over probably the next 20 years. So that means lots more training to bring new people up to speed. So what are some of the things the ESCO can do to support performance? It can help the operators understand what a reasonable level of set point flexibility is and where it's going to actually cost you serious money in your savings. Show them how to interpret trend data, help them figure out their role in the overall optimization of system performance, and help them understand how the whole thing works together, and also understand the difference between short-term versus long-term operational solutions. This one's really important because a lot of times anyone who's operating major pieces of equipment, they're often doing something to respond to a short-term operational need, which may be appropriate, but they need to understand the long-term operational consequences of the decisions and consider if there maybe are alternatives, either in duration or degree of adjustment and things like that. So just to recap of some of the success factors for M&V, you need a timely method to measure the savings. It's got to be cost effective, clearly defined, and reasonably accurate. And that may seem simple, but if you do those 4 basic things, you're doing a lot if you do them correctly. Now we're going to touch on a few examples of ECMs here as M&V examples at your specific project. You decided on using option A for the well pump replacement measure, and the baseline pump efficiency was calculated based on measured power, utility consumption, gallons pumps, and well height. So you're focusing there on key variables that determine a lot of the future operation and consumption profile of that pump equipment. And by looking at those particular factors, you're getting a good picture of what was occurring during the baseline period. Then you're modeling the energy savings with calculated baseline efficiency and a proposed new pump efficiency. Then throughout the performance period, you're going to be monitoring the pump energy use and flow using a SCADA, which will confirm that the pump performance and savings are as expected. So this is the comparing performance to the targets, which we talked about earlier. I don't know, Aaron, you want to make any other comments on that particular approach for the pump?
No, I think you nailed it. I mean, the idea with specifically these pumps is that the operation doesn't vary too much. There's no any drive controls or anything like that. So that was the thought process behind option A.
Yeah, there's not a lot of variability, so there you go.
Dave, this is Mark Chan. So specific to this one, and granted these are more details than you would see right now, but we have maybe multiple pumping units at this station, and they go through a common flow meter. So from the standpoint of option A, M&V for this one, would we say that during that year, we actually just have a measuring point where we turn off all the other units and just turn on that one unit, run it through the flow meter, measure it, and that's the numbers that you would use to verify that it is meeting the performance?
That might be one way you could do it. I'd have to know a little bit more about the technical configuration.
Sure.
Maybe I'll ask Aaron to comment on that.
Yeah, so the way we actually set up the model, you don't actually need to do that. Given that these sites, 90 plus, 95, 99% of the electrical usage is from those pumps, it's very easy to see when one stage is on and one stage is off based on the flow data. You're not gonna, you're gonna go up from 1.5 MGD to 3 MGD. You can tell immediately when another pump turns on. And so you can use that as your guideline for when one pump is running, two pumps are running. Because there's no variability, they're just on off, it's really easy to tell exactly what's happening at any given point, given the SCADA data.
You have what we call a very chunky load profile. It's on or it's off, and when it comes on, it's on in a big way.
Right. Okay. No, fair enough. Okay.
Yeah. Here's another example. Going into the calculation detail in a little bit more detail, where they talk about using a spreadsheet tool to calculate the existing pump wire-to-water efficiency using measured pump power and recording the flow from the SCADA system using the following formula. And I don't know, I'm assuming this is something when you were negotiating your M&V schedule that Will or Aaron or someone else probably talked you through the equation, but it's probably nothing that's especially novel to you in terms of the wire-to-water efficiency, in terms of the layout, because you're really measuring, here's horsepower, there's horsepower, here's the kilowatt hours, and it's pretty straightforward, relatively speaking. Unless there's something you want to discuss about this formula.
No.
Okay. Then the last thing on this example is just talk about how they used the annual flow data was collected from each well using the SCADA system, and common pumping configuration was looked at during the baseline period. Post-installation, now this might be interesting. How are you going to do the commissioning and testing on the well pump replacements? What's your commissioning process for that? Maybe you could comment on that, because that's relevant.
So the commissioning process will be kind of a normal startup procedure that BWS is most likely used to. You're going to go through your system checks, your component checks, mechanical systems, things like that. Mm-hmm. You're going to go through all of your control checks and things like that to make sure that the pump is actually operating the way it should. You're going to look at performance via the SCADA and via local gauges, to make sure all the pressure and things like that are where you'd expect them to be. Mm-hmm. That's sort of commissioning. That's sort of the get you off the ground to start your M&V. And once that's complete, that the system is up and running and operating as it was designed, and then you go from there with from the baseline activities with the model to verify the savings.
And I'm assuming that the object of your contractor quarterly reports is to try to maintain original design performance. Could you say a little bit more about the content of what will be in those quarterly reports?
Sure. The idea of the quarterly reports is to have a record of the condition of the pumps, to see where they are operating with reference to the design points, mm-hmm. So that is like kind of like your baseline moving forward, to know that you are operating within the expected parameters. Mm-hmm. It's sort of your check on the SCADA data that you're using over time.
Gotcha. All right, well, believe it or not, that's the last slide, so I guess I'll throw it open to any questions or discussion for anyone who's so inclined. I know we got started about 15 minutes late, but we did a pretty good job of using up the time.
No, you did an excellent job, Dave. For anybody else, this is actually originally scheduled to be two-hour sessions, I believe. So you managed to squeeze it into 2.5 hours. So thank you very much for Dave for doing that.
Sure.
Are there any questions out there, especially those who don't have mics? If you guys want to type it in, I'll go ahead and read it out loud, because that way it gets recorded. So any questions out there?
Well, this is Dave Nagamine. While other people type in or think about their questions, Dave Burr, the question is, what would you see as a good M&V team comprised of BWS as well as the RESCO people? They would be looking at course, guaranteed savings.
Mm-hmm.
It would be looking, one of the benefits we would like to see is optimizing and getting more savings.
Mm-hmm.
And so, what would you visualize as a good team?
Well, I mean, you probably know your internal staff better than I do in terms of the availability and training and capabilities, etc. But I would say it's good to have a dedicated person as sort of the project champion, or I'll call it the project performance champion, designated by the Board of Water Supply, whoever that person is, and obviously having some orientation like this to the background of understanding the M&B process and activities would be very helpful. NORESCO will typically designate, I would say, they have like a whole M&B department, but typically there would be, whoever is the project developer, I'll call them M&B person, and then they have their own support personnel for more complicated M&B issues. But once again, NORESCO would be the best person, or best to tell you who they would be assigning from their side to be involved. It's typically not going to be more than a couple people, I would guess. I mean, Aaron, you can correct me if I'm wrong, but I don't imagine your M&B activity is going to involve more than 2-3 different people from NORESCO, is it?
Probably over the long run, it'll be just a couple people, basically 1 to 3, and getting established will probably be more than that. It'll probably be our engineering teams with our development teams, our construction, and then with our M&V to kind of kick it off. And then going forward, it would be more of our M&V group, the people that you kind of get used to on a day-to-day. You kind of have one person from NORESCO, one person from BWS who interact on a day-to-day or week-to-week, and then more people as the time interval increases, like every year or further on.
Yeah, I would say also, David, that it's good to have the operation and maintenance staff looped into this, because the way they interact with a project can have a big impact on the performance. And so however that is structured, having someone who's sort of a champion on that side of it to help optimize performance is really helpful. And once again, I don't know internally how you're set up in terms of who that person would be. You may have a better handle on that than I do, but who would work sort of hand in hand with the more engineering focused M&B champion to also be the operation and maintenance focused M&B champion, or to make sure that there's access when NORESCO needs it, and also an active cooperation with the whole optimization strategy. But I think that's, when you're talking about a team, that's what I would be looking for, those types of components. I mean, in some cases, like at DOT, I've actually had a bigger role than I really anticipated, partly because they have not involved their own staff as heavily as I thought they might. And so I've ended up doing quite a bit on the review of M&B reports, I'll put it that way at least. But that was their decision. I mean, they could have done it another way in terms of their internal configuration.
Okay, and then related to that M&B team, should there be regular meetings or?
Well, as I think, at the early stage, usually the first year of M&B is quite active, just because you're putting all these procedures and processes in place, and you're doing quarterly reports and the first rounds of inspections, etc. And there may even be data that comes in during the construction period that you want to look at and evaluate in some way, because it's going to have an impact on what you do in the future in M&B. It's something you discover during construction that's going to affect how you proceed going forward with M&B, things like that. But I don't know. I mean, I would say when you have actual M&B data to evaluate, then some sort of meetings for review and appropriate response is good. A lot of times, in my experience with DOT, a lot of times I was waiting for data. So I would be requesting a lot of information, some of which JCI had and some of which they didn't have. and they would have to go collect it. Then once they got it together, then it was productive to get together and actually have a review meeting, and we had many of those. But it was hard to put it on a really regular schedule because sometimes you're sort of driven by dependency on data. And until you have the information you need to evaluate and analyze, not a lot of reason to have a meeting. So it's hard to set like I'll say a priori schedule. But, periodically, yes, it'll be very useful to get together and review available M&B data. It's more a question of what it is, when it's available, and what you need to do with regard to it.
Okay, thanks.
Sure.
Dave Burr, this is Mark again. We have sort of related questions. First one, the assumption is that it is a team to look at the reports and all that. In your experience, yes, have other customers brought in finance or budget people into this type of review team? Is that usually critical for this?
They usually do bring them in, and usually the hardest part is the engineering staff having to educate budget and finance, in my experience. And, I've had many meetings with finance people, and often it starts off with the proclamation, well, I'm not an engineer, but it seems to me we should just be able to look at the utility bills and see that, hey, we're getting our savings or we're not getting our savings. And then you go into an 87-slide presentation like the one I did here today explaining to them. It's not really quite that simple. You have to understand that different variables can affect what you see on your utility bill, and unless you take them all into account, you couldn't make a comparison unless you normalize the utility bill comparison and account, separated the signal from the noise, and so forth. So, but yeah, I would say they typically do get involved. The important thing is whether they have a good relationship with the engineering staff they're working with, and you're credible, you have credibility with them, and they trust and understand what you're saying, up to the point that they're willing to defer to your technical judgment in terms of your analysis of the M&B, etc. That's probably, I would say, an important factor. If you get someone who's basically saying, I'm not an engineer and this isn't the way it should be different, even though I have no idea technically what you're talking about, then you might have an issue.
Okay. Okay. The other question I had is, from a customer's standpoint, does it behoove us, or is it normal for us to be kind of reviewing data even before the M&B report shows up annually? Like,
Sure it is. I mean, let me put it this way. I don't necessarily encourage people to try to ask for an M&B report during construction, which is what DOT actually did. They were still building the project out, and not that much of it was even installed in the first year, and they still made them do an M&B report. Well, they had a reason for doing it because of the way they were financing the project, but it makes it very hard because you're spreading out, you don't have everything that you need, and the data is sort of trickling in. So you run around spending a lot of time chasing stuff down. It's fine to do a certain level of monitoring and collection of data during the construction period, and I'm actually sure that NORESCO will be doing some of that. And it's fine to schedule some time to review and analyze that. But to actually spend the money to do a full M&B report during construction, you have to have some overriding financial reason to want to do that, which in the case of DOT, I believe they thought they had, which is why they did it, but it made it very labor intensive, I'll just say that.
So even after construction and you're in your regular 17
Yes.
days worth, I'm wondering if it's worth it for me to say have our staff, Board of Water Supply staff, go out there and maybe do spot measurements kind of in preparation that an M&B report's going to come, or is it more typical just to wait? Let's see.
Well, let me put it this way. No, I would confer with NORESCO about that and talk about what makes sense. If you want to do some spot measurements on your own, there may be a way in which that could be supportive of the optimization process. And if you undertake that on sort of your own dime as part of your regular activities, that might be perfectly appropriate, as I'll call it, sort of a continuous monitoring-based commissioning strategy. But I would sit down and work out the technical details of that in conjunction with NORESCO.
Sure.
And then you can figure out what makes the most sense, because there might be measurements that make a lot of sense to do that are helpful. There might be others which would just be sort of a waste of your time, and like, why do them?
Yeah. Okay. No, fair enough. Thank you.
Yeah. Sure.
Okay. Okay. Well, are there any other questions out there from anybody?
No. Thanks.
Okay. Well, with that, let me just stop the recording first.